Hi, this is John Isles and welcome to Geometer's Paradise. Today we're looking at lesson 3-2 called Deduction. We're going to go through several different things today. Counterexample is our first agenda, then detachment, and finally syllogism. So, first of all, every statement, conditional or not, is either a true or a false statement. True statements have meaning and that we can trust the statement to inform us based on its content, and false statements are thrown out. Okay, we are mostly concerned in geometry with observing the world of shapes and lines and devising relationships for what we see. Sometimes our observations will lead us to a new theorem, and sometimes we discover a counterexample that tells us that our thoughts have taken a wrong turn. A theorem is a conditional statement that has been proven true, and a counterexample is a statement that shows that a conditional is false. We write a proof to show that our observations are true. Now, not being able to find a proof doesn't necessarily mean that a conditional statement is not true. So there are many unsolved proofs out there, and that doesn't mean that they're not true. So usually, if we can't find a counterexample, we usually take a proof to be true, even if we don't actually have a proof for it. Alright, so the first thing we want to talk about is counterexample. So to find a counterexample, you want to just think about a conditional statement and see if you can come up with any circumstance where the statement is not true. And so here we have a series of absurd conditionals. So for the first one here, the example, if the lawnmower runs out of gas, then you will have to go buy more gas. This seems logical, right? It sounds true. You run out of gas, you're going to have to go get some more gas. Well, maybe you don't have to buy the gas though. Maybe you've already bought the gas and it's just in a container in the garage. So you don't have to go buy more gas. Instead, you're just going to go get the container to fill up your lawnmower. So that would be a counterexample to this conditional statement, because the second part has to come true. And we can't have any kind of circumstance where we run out of gas and then don't have to go buy more gas. Okay, and then we have some examples here, and we'll go over these in the solutions video. Alright, detachment. The law of detachment is one of two kind of fundamental rules of logic. The law of detachment basically says that if you have a circumstance that fits the condition, that fits the hypothesis, then you get to make a new statement that fits the conclusion. Alright, so take this conditional statement. If you run a mile, then you will burn about 100 calories. This is actually scientifically accurate, roughly. It varies from gender to gender and you know, body mass and whatever, but basically, if you run a mile, you're going to burn about 100 calories. Alright, so if I then say something like Judy runs a mile, that has a significance. She's going to burn 100 calories. Alright, it's going to happen. So you can make that new statement. And again, we'll go through these two when we look at the solutions document. Now, a syllogism is a logic rule, comes from a Greek word, and it's a logic rule that merges two statements into a third. The first statement is called the major premise, the second is called the minor premise, and the result is called the conclusion. For example, the major premise would be, in this first set, is all humans are mortal. The second statement, the minor premise, is that I am a human. And the conclusion is that, therefore, I am mortal. Since I'm human, and all humans are mortal, I am mortal. So that's what we call a specific syllogism. We can also have a universal one, like all humans are mortal. All mortals will die. So all humans will die. basically we are connecting the major premise with this idea, this conclusion in the minor premise that allows me to make some kind of final statement. Alright, so this syllogism is universal because it contains the word all in it. This syllogism is specific. It is not universal because it contains the word I, a specific person or a specific creature, whatever. And it's because of the minor premise being specific that the conclusion is specific. Here the minor premise is universal, so the conclusion is universal too. We'll go over these examples in the solutions video. Alright, this is also going to be in the solutions video, but this is a proof. We have 6 ideas here that we can use to write the proof. And we begin a story. It's getting late, and Gertrude the elephant was visiting Old MacDonald's farm. She was sleepy. So what we want to do is use these 6 ideas: that all elephants can lie down in a barn, that all dark corners are good hiding places, that all elephants are afraid of mice, that if you are afraid, you will try to hide. If you go into a barn, you will see a mouse. And if you are sleepy, you need to find a place to lie down. Alright, so when we write this proof, we're going to use these rules and either detachments or syllogisms to accomplish our goal.